Hello friends, welcome you all. So in this video, we are going to start one more mathematical model which is known as Turing Machine. And we will discuss the working of Turing Machine first, and then we will discuss the triple definition of Turing Machine or mathematical definition of Turing Machine, or you can also call it formal definition of Turing Machine. So I will start with working of Turing Machine. So first of all, I will tell you, friend, it was first proposed by Alan Turing. So after his name, after the name of Alan Turing, this machine is, or this mathematical model is known as Turing machine. So this was given by Alan Turing in 1936, and it was considered as first working computer. So Turing machine is almost equivalent to computer. Whatever you can do with computer, you can do with Turing machine. So I will discuss first the working of Turing machine, and then we will discuss its formal definition. So friends, suppose this one is your Turing machine. So it is having one head, and it is also having one tape. This tape is divided into different locations like this, and it is infinite at both end. It is infinite at both end, so it is called tape, input tape. But and in this particular machine, this is read write head. In all mathematical model that we have discussed till now, this head was read head only. But in Turing machine, this is read write head. So this is the biggest benefit of Turing machine, that it is able to read as well as write onto the tape. So input symbols are given on this tape, and Turing machine can read this tape and the input from this tape, and as well as it can replace the input or any symbol that it is reading with another symbol. So it can read from the tape and it can write on the tape also. So this is the biggest benefit of Turing machine, and because of this capability, it can work as a real computer. So now, as we can see, the working of finite automata, working of PDA, like after reading one input symbol, the all mathematical model changes their states. So the Turing machine also work in the same manner. So after reading one symbol at a time from input tape, Turing machine changes its state, and after reading one symbol at a time, one by one, all input symbol, it continue to change its state. And after reading complete input, suppose as I told you that this particular tape is infinite at both end, so in somewhere in the middle of this tape, your input may be written. So like A, B, B, B. So this is your input. Now, remaining all locations would have one blank there. Like epsilon, the input tape in Turing machine contains blank. So when Turing machine starts working, its head is placed at first position, first input symbol on the tape. And one more benefit of this particular Turing machine is this head can move in both direction. In both direction, it can move. Like it can move from left to right as well as right to left. And all mathematical model that we have discussed till now, the read head was there, and it was capable of moving from left to right only. But in this particular machine, Turing machine, This head can read symbol from the tape as well as it can write symbol on the tape. And one more capability is there, it can move in two direction. It can move in left direction or it can move in right direction. So from left to right it can move, from right to left it can move. So it can move in both direction. After reading one symbol from input, Turing machine changes its state and also move in right direction or left direction. And after reading complete input, it reads blank. And after reading complete input, if it is in the final state, if it is in the final state, then this particular string is considered as valid string. And otherwise it is considered as invalid string. So this is how Turing machine works. Now, as uh, finite automata works in two different way, like some finite automata can produce output based on the input, and some finite automata accept only accept the given string or only validate the given string. So in this way, Turing machine also can work in two different way. So when it is validating some kind of string from any given language, then this Turing machine is known as acceptor kind of Turing machine. Acceptor Turing machine. Acceptor Turing machine. Now, if Turing machine is generating some output based on the input, then such Turing machine is known as transducer Turing machine. So there are two kind of Turing machine: acceptor Turing machine and transducer Turing machine. Both kind of Turing machine we will discuss in this playlist. Now I will tell you the mathematical definition of Turing machine. Now I will discuss the formal definition of Turing machine, or you can say triple definition of Turing machine. So like PDA, Turing machine also has 7 tuples. Turing machine also has 7 tuples. So which are capital Q, then Q is set of all possible states of machine. Then second is sigma. Sigma is set of input symbol. Then next is gamma. So here gamma is set of tape symbols. Then we have transition function delta, which is transition function. So transition function of Turing machine we will discuss in detail. Transition function. Then we have Q0. Again it is single state, which is initial state. Then you have in place of Z0 here, which is initial state symbol in PDA, you have B, which is known as blank. Then you have F, which is set of final state, set of final states. So these 7 tuples are there in Turing machine. In some places, you may find some different tuples there. Here in place of B and F, you can find Q reject and Q accept. These two can be replaced with rejection state and acceptance state. So some in some textbook you may find in place of B and F you can find Q reject and Q accept. So we have 7 tuples in Turing machine. So this is the mathematical definition of Turing machine. Now I will discuss transition function of Turing machine in detail. Always Turing machine would be in some state which is known as current state. So this current state would be coming from Q, and after in that current state it will read some symbol from the tape which is input symbol, as I told you earlier, like input symbols are also written on a tape. So all sigma element of sigma are also there in gamma. So so tape symbols are represented as gamma. So in machine will be in current state, and in this current state it will read some symbol from tape, so it would be represented as gamma, and then based on that combination, machine will change its state to new state, so which will again be coming from q, and then it can change the current symbol in some different symbol, or it can leave it as it is. So again the tape symbol will be coming from gamma. And one more thing there, as I told you, that read and write head can move in any direction. It can move to left direction or it can move to right direction. So it will either move to left direction or move to right direction. So this direction is mentioned with each of the transition of Turing machine. So these are the two options of direction, left direction and right direction. So this is how the transition function of Turing machine is represented. So I hope this would be very much clear now. And when for one combination of current state and current tape symbol, you have only one new state and one tape symbol and one movement either left or right, then it is known as deterministic Turing machine. Deterministic Turing machine. So this particular transition function is for deterministic Turing machine. And if I want to create transition function for non-deterministic Turing machine, so here we can have more than one options of same kind. So I can represent it as q cross, I can mention like this, q cross gamma, then 2 to the power q cross gamma cross left or right. So this would be the transition function of non-deterministic Turing machine. So I hope, friend, it would be very much clear. Now in next video in this playlist, I will take some example of Turing machine creation, how we can accept some string from any language by Turing machine with the help of Turing machine, or how can create output with the help of Turing machine. So I hope it would be very much clear. Now if you have any doubt, you can always write to me in comments. I will definitely reply your comments. Thank you so much.